This is grade 4, chapter 15, where we will be teaching you about decimals. I know, you're probably thinking, we've did this before, but this is something different, trust me. Now for the first section, we're going to be talking about rounding decimals. You can use a number line to help you round decimals when you're finding where it is in relation to your nearest whole number. But honestly, rounding decimals is like rounding any other number. So if you're rounding to the nearest whole number, you look at the 10th value and see if it's greater than or equal to 5, or if it's smaller than 5. If it's smaller than 5, you just round down. If it's greater than or equal to 5, you just round up. See, it's like any other number. So instead of using the number line, let's do some practice. So round 8.3 to the nearest whole number. So we think 3, which is in the 10th place, is smaller than 5. So we have to round down. So 8.3 rounds down to 8. And now we're going to move on to the next question. Round 9.8 to the nearest whole number. So we think 8 is bigger than 5. So we have to round up. Therefore, 9.8 rounds up to 10. Yay! Now let's do some practice problems. Round to the nearest whole number. You can use a number line if you want, again, but you really don't need to. 8.6. What's in the 10th place? Well, 6. Is 6 greater than or equal to 5? It's greater than 5, so we have to round up. And what is the number above 8? 9. 8.2. Is 2 smaller than 5? Yes. So we have to round down. Now, if we're going to round down, we're just going to get, well, 8. 9.8. Well, we just did that up here, but 8 is in the 10th place. 8 is bigger than 5, so we round up to 10. 9.5. 5 is equal to 5. And I know that it's a midway point, but usually, at least in lower grades, like right now, we would round up. There's more specific guidelines and requirements once you get into higher grades, but for now, we just round up. If it's 5, we round up to 10. 9.1. 1 is in the 10th place. 1 is smaller than 5, so we round down to 9. 9.3. 3 is in the 10th place. And, well, 3 is smaller than 5, so we still round down. 8.4. 4 is in the 10th place. 4 is smaller than 5, so we round down to 8. 8.7. 7 is in the 10th place. So we round up, because 7 is bigger than 5. To 9. Okay, now that we're done that, we're going to learn about rounding to the nearest 10th. So instead of looking at the 10th place, like we do for rounding to the nearest whole number, we look at the 100th place. I.e., we just look at the place that's 1 to the right. We can use a number line if we want, again. For example, round 1.56. You can tell that 1.56 is closer to 1.6 on a number line. So you round up. But you can also look at the 100th place. 6 is bigger than 5, so we have to round up. Therefore, 1.56 rounds up to 1.6. 1.60 and 1.6 are the same thing. And now we round 1.61. We can tell on a number line that it's closer to 1.6 than it is to 1.7. But we can also do it without a number line, because number lines are actually pretty difficult to draw if you don't have a ruler, and chances are you might not have a ruler on a test. You look at the hundredths place, it's a 1. And is 1 smaller than 5? Yes. So we have to round down. Therefore, 1.61 rounds down to 1.6. So let's do some practice problems and forget about the number line. Round to the nearest tenth. 1.52. What's in the hundredths place? 2. Is 2 smaller than 5? Yes, so we round down to 1.5. You can put 1.50, but that's a little bit extra. 1.59 is, well, the hundredths place smaller than 5? No, so we have to round up to 1.6. 1.55. The hundredths place is 5. This is halfway between the 2 points. But remember, for halfway points, we still round up. So this is 1.6. 1.51. The hundredths place is a 1. 1 is smaller than 5. So we round down to 1.5. 1.64. Well, 4 is the hundredths place. 4 is smaller than 5. So we also round down to 1.6. 1.63. The hundredths place is 3. 3 is smaller than 5. So we round down to 1.6. 1.68. 8 is, well, bigger than 5. So we round up to 1.7. 1.66. 6 is still bigger than 5. So we still round up to 1.7. Well, that was quick. Oh, by the way, guys, if you want to take a break at any time during the video, you can pause it and take a break. Go do some practice problems, have a drink, eat a cookie, go to the bathroom, do whatever you guys do during breaks. So yeah, but now we're going to move on. If you want to pause it, feel free. So now we're going to do some estimation in section 2. Oh yeah, I remember somebody that I knew back in elementary who would say, "Oh, I made an educated guess." Whenever the teacher asks them how they did the question and they actually didn't know, they just say, "I made an educated guess." That's like saying estimate. Decimal sums and differences. To estimate the sums of decimals, round each decimal to the nearest whole number, then add the rounded numbers. You could do that, although it's not the best way that I've ever thought of, or you would ever come across, but it's good for really, really quick calculations, like you're just looking at your receipt that you got at the mall or the store and you're like, hey, did something add up wrong? And then you just do an estimation and you find that it's a little too far off. Yeah. It's good for quickness, but it's not that good for accuracy. Round each number to the nearest whole number. So over here it's 22.52. Now we look at the tens place. It's a 5. And what do we know about halfway points? Well, we round them up. So it rounds up to 23. 4.49. It's really close to 4.5, but it's not. It's a 4 in the tens place, so we still round down to 4. This would make it 23 plus 4. And then we add 23 plus 4 equals to 27. So 22.52 plus 4.49 is about 27. This is actually a really close estimate, by the way. Round each number to the nearest whole number. You could also do this for subtraction. So for this one, it's 6.25 minus 4.79. So 6.25. The tens place is a 2, so we round down to 6. And 4.79, the tens place is a 7, so we round up to 5. And then 6 minus 5 equals to 1. So $6.25 minus $4.79 is about $1. It's actually $1.46, which is kind of off, but it's an estimate. Now we're going to do some practice problem. Estimate, round to the nearest whole number, show how you rounded. So, 5.89. Tens place is an 8. Is 8 bigger than 5? Yes. So we round up to 6. 4.29. Tens place is a 2. Is 2 smaller than 5? Yes. So we round down to 4. Therefore, 6 plus 4 is, well, 10. So 5.89 plus 4.29 is approximately around 10. 17.3 plus 5.67. Okay. 17.3. 3 is in the tens place. Is 3 smaller than 5? Yes. So we round down into 17. 5.67. 6 is in the tens place. Is 6 bigger than 5? Yes. So we round up to 6. And we get 17 plus 6, which is equal to, well, 23. That would be an estimate. And we move on. 8.48 plus 3.07. Now, 4 is in the tens place for this one, and 0 is in the tens place for this one. Both of these numbers are smaller than 5, so we round them both, well, down. So then we get 8 plus 3, which is equal to 11. Or, well, the approximation would be 11. And in this one, 7 is the tens place, so we round up because 7 is bigger than 5. And we get 7. Over here, 2 is in the tens place, which means that we round down because 2 is smaller than 5 to 3. And we get 7 plus 3 equals to 10. So 6.7 plus 3.2 is approximately equal to 10. It's actually equal to 9.9, which is pretty close. Now we have money. And this estimation is going to be a little bit off because both of these are going to be going up, since 9 is bigger than 5 and 5 is equal to 5, which means that both of them round up into 16 and 3. So 16 plus 3 equals to 19. Therefore, we get 15.95 plus 2.59 is approximately $19, because this is all money. Now we move on to, well, other questions. Oh, this is the last addition one. Over here, the tens place is 7, so we're going to round up into 26. And over here, the tens place is 9, so we're going to round up to, well, 9. And we get 26 plus 9 equals to 35. Which means that 25.7 plus 8.9 is approximately equal to, well, 35. Or our estimate is that it's equal to 35. 14.25 minus 7.84 is our next problem. And since we're rounding to the nearest whole number, 2 in the tens place means that we will be rounding down, and this will be 14. 7.84, 8 in the tens place mean we'll be rounding, well, up. And that would be 8. Which means that over here it's 14 minus 8 is, well, we know it's 6. So that it's implying that, well, 14.25 minus 7.84 is approximately 6. It's a little bit off, but it's an estimation. It's always going to be a little bit off. So 10.97. 9's in the tens place. 9 is obviously bigger than 5. So we're going to round up into 11. 7.4. Well, 4 is in the tens place this time, and it's still smaller than 5, so we're still going to round, well, down into 7. 11 minus 7 is equal to 4. So the conclusion is that 10.97 minus 7.4 is approximately equal to 4. Now we move on to 3.62, and 6 is in the tens place, so we round up to 4, minus 1.87, 8's in the tens place, so we still round up and we do it to 2. That means that 4 minus 2 equals to 2, which also is saying that 3.62 minus 1.87 is around 2. Over here, we have 10.25. 2 is in the tens place, so we round down to 10. And 3.45, 4 is in the tens place, so, well, it's smaller than 5. We're still rounding down to 3. 10 minus 3 is 7, which means that 10.25 minus 3.45 is approximately equal to 7. Well, they're 0.2 off, which isn't that bad. So 10.54, 5 is in the tens place, so we're rounding up to 11. Minus 7.81, well, 8's in the tens place, so we're going to be rounding, well, up again. 11 minus 8 would be 3. It's better to add a dollar sign here, considering that this is talking about money. Okay then. The conclusion statement for this would be, what do you think it would be? Well, it's $10.54 minus $7.81 is around $3. That's long-winded. But now we're going to move on. 43.7, 7 in the tens place, which means that it's going to do what? It's going to round up into 44. And then 20.48. 4 is in the tens place, which means it's going to, well, round down to 20. 44 minus 20 equals to 24. Therefore, 43.7 minus 20.48 is approximately equal to 24. Now we're going to work on some problem-solving strategies, such as work backwards. Let's read the question. Paul had $8.25 more yesterday than he does today. Yesterday he had $12. How much does Paul have today? So what do we know? Paul had $8.25 more yesterday than he does today. Yesterday, Paul had $12. So what do we need to find? We need to find how much money he has now. Carry out our plan. We know that, well, Paul had $12 yesterday. And we know that he had $8.25 more yesterday than he does today. Which means that today he has $12 minus $8.25, which means that he has $3.75 or $3.75. So how could we check the answer? Well, we could decide to do 3.75 plus 8.25. And if we get 12, then our answer is correct. But do we get 12? Let's see. Yes, we do. So of course, we also need to reread the problem. Paul had 8.25 more yesterday than he does today. Today he had 12. Well, yesterday he had 12. How much does Paul have today? Well, we got our facts straight. What other strategies could we use to solve the problem? I mean, we could just... Technically, we couldn't really use any other strategies. This is one of those types of problems where we just do it backwards using logic. So technically, logical reasoning is a part of this. But, well, math is a part of all of them, so that's not the strongest argument you could get. So using the work backwards strategy, we are supposed to solve these two problems. Sally had $10 less yesterday than he has today. Yesterday, she had $13.30. How much does Sally have today? In this question, it says Sally had $10 less yesterday, which means that she gained $10 from yesterday. So the mathematical equation would be, well, sentence, I guess. You could also say it like that. To what she has today. So what is this? Well, it adds up to $23.30. Is what Sally has today. Now we move on to the second problem. Lim and Roy walk to the library. Lynn walks twice as far as Roy. Roy walks 4 miles. How far does Lynn walk? So Roy walks 4 miles. Lynn walks twice as far, times 2. 4 times 2 equals 2? Come on, guys, you learned this in grade 3. 8. Lynn walks 8 miles. Make sure that the unit of measurement is the same, because walking 8 miles and 8, centimeters is kind of different. Now we're going to talk about adding decimals. We're finally getting onto the fun stuff. So we can use models. Like, let's say we have 1.34 and 1.28. We can color 1.34 dark gray, and then we can color 1.28 with stripes, and then we count the number of squares we shaded. But come on, guys, which one of you is actually going to draw all of this? No, seriously, which one of you? On a test? No, you're kidding me. No, you can't. You don't use this on tests. It takes too much time, and it's tedious, and nobody's going... If you keep doing this in a higher grade, people are going to laugh at you. There are 2 whole grids shaded and 62 out of 100 shaded in the 3rd grid. So 1.34 plus 1.28 equals to 2.62. Guys, come on, guys. You've been adding 3-digit numbers since like a while ago. So we just use paper and pencil, and we just add each place and we regroup if we need to. That's what we're going to do. Because, fun fact, if you are going to draw all that, your hands are going to die, and your brain isn't going to get enough practice for tests, and you're going to be slow on tests, and chances are you're going to fail. So, now, 1.7 plus 1.4. We're just going to use vertical form, or just, I like to call it stacks. 4 plus 7. 1, Do we need to regroup? Yes. And then 1 plus 1 plus 1, 3. 1.7 plus 1.4 equals to 3.1. When you're adding decimals, line up the decimal place. Don't line up anything else, just the decimal place needs to be lined up. Now, we move on to 1.24 plus 0.38. 8 plus 4, 12. We regroup. 1 plus 2 plus 3, 6. We don't need to regroup. 1 plus 0, 1. We don't need to regroup. And we get, well, 1.62 because we drag the decimal down. Over here we have 0.5 plus 0.8. 5 plus 8 equals to 13. And then we regroup and we get 1.3. Over here is what I was talking to you about. Align the decimal places. Don't do, well, this. No, no, no. Just no. N-O. You line up the decimal places. You can use 0 over here as a placeholder, but you actually really don't need it, at least for addition. So over here it's just 5. And then 3 plus 5 equals to 8, decimal place. 1 plus 1, 2, 2.85. 1.5 plus 1.35 equals to 2.85. 2.25 plus 1.03. Three plus 5 equals to 8. We don't need to regroup. 2 plus 0 equals to, well, 2. And then 1 plus 2 equals to 3. The solution to this is 2.25 plus 1.03 equals to 3.28. I know that the instructions may tell you to use models. Honestly, that takes too much time, so. And then we have 1.52 plus 0.35. 5 plus 2 equals to 7. 3 plus 5 equals to 8. You put the decimal point there because it's all lined up. 0 plus 1 equals to 1. Done. We move on. 0.9 plus 0.8. What's 9 plus 8? 17. You regroup, and it becomes, boom, 1.7. Over here, it's, personally, I like putting the bigger number on top, but you could do both since it's addition. 5 plus nothing equals to 5. 6 plus 8 equals to 14. We regroup. 1 plus 1 plus 0 equals to 2. We put the decimal on, and we get 2.45. Then we have 0.85 plus 0.15. So we have 5 plus 5 equals to 10, and then we regroup. 1 plus 8 plus 1 equals to 10 again, so we regroup again. And 1 plus 0 equals to 1. This just equals to 1. You could put 0.00 if you want. If it's money though, you have to put it, but right now it doesn't really matter that much. 0.8 plus 0.6. 6 plus 8 equals to 14. You regroup, you put the decimal there, and then you just get 1.4. See, it's much easier and less time consuming if you just use math. Now we're going to move on to problem solving investigations. Okay, guys, remember that you can pause the video at any time, okay? Whenever you want to break, do some practice problems, yeah, you can pause it. But we're going to move on right now, so if you want to pause it, go ahead. If you don't, just keep going. There are many ways to solve most math problems. Mind equals to blown. You will decide which strategy works best for you when you read the problems. Yeah, that's usually how it works, you know. James, Abigail, and Chris each play soccer. James' jersey is not blue. Abigail's jersey is not blue or black. Neither of Chris' two jerseys are green. The colors of James' jersey does not begin with R or J. Okay, so what do we know? We know, well, this entire block. What do we want to find out? Who has what jersey? So we can use logical reasoning to logic our way out of this. Now, we have James. We can make a table at the same time, too. Abigail, I'm just going to put A and C. J-A-C. James' jersey is not blue. Abigail's is not blue or black. Black, I'm just going to put B-A. Chris' jersey. Oh, he has two jerseys? Really? Really? Isn't green. And the color of James' jersey does not begin with R or G. So I'm assuming red is also another color. So James has a black jersey. Yeah, that's about it. Abigail can have green or red. And Chris can have anything... Oh, wait. Yeah, Chris can have anything that isn't green. Check to see if we're correct. They each play soccer. James' jersey isn't blue. It's not blue. Abigail's jersey is not blue or black. Neither of Chris's two jerseys are green. The colors of James' jersey does not begin with R or G. Okay, so our facts. We don't have enough facts to actually give a, well, clear, not exactly clear, but concrete answer to this, except that James' jersey is probably black. So everything that we have over here fits with the facts, so this is correct. Now, we're just going to do some practice problems. Use any strategy shown below to solve. Tell what strategy you used. Okay. The R train comes every 42 minutes. That's a weird name for a train. The next time the R train will arrive is 10:23 a.m. What time did the R train last come? So the next time the train will arrive is 10:23. The train comes every 42 minutes. Logically, it's just 10:23 a.m. and then you go back 42 minutes. So, what's the answer? Well, it's 9:41. The R train last came at 9:41 a.m. Our strategy is technically logical reasoning. You can use a different strategy than me. Just gonna say that. These are just, well, the answers. The number of acorns on the sidewalk doubles every 6 hours. Oh, okay, that is kind of scary. Just imagine the acorns just double. Anyways, after one day, there are 96 acorns. How many were there at the beginning of the day? So, how many 6 hours are in one day? Well, one day is 24 hours. 24 divided by 6 is, well, 4. So we're technically working backwards here. Since it doubles every 6 hours, 96 divided by 2 equals to 48 divided by 2. Because, well, we need to have 4 divided by 2's. Equals to 24 divided by 2 equals to 12 divided by 2 equals to 6. There were 6 acorns at the start of the day. Now we can decide to just, well, check it. Now we think. Beginning of the day. After 6 hours, it would be 12 acorns, and then after 12 hours, it would be 24 acorns. After 18 hours, it would be 48 acorns, and then after 24 hours, it would be 96 acorns. Yep, it makes sense. So now we move on to the third question. Tim bought 4 books for $16. If each book costs the same amount, how much would 15 books cost? What are the strategies again? Well, we could use logical reasoning, or we could solve simpler problems. Now, what's 16 divided by 4? 4, right? So each book costs the same amount, which means that each book costs, well, $4. What's 4 times 15? $60. It would cost $60. Now, if you really want to check this, you could do 60 divided by 15 equals to 4. 4 times 4 equals to 16. Done. Now we move on to question number 4. Two numbers have a product of 48 and a difference of 8. What are these two numbers? Oh, this is like algebra. Annoying. So many numbers can have a difference of 8, but not that many can have a product of 48. So what numbers can have a product of 48? Well, the simpler problem here, technically. Technically, it's solving a simpler problem. Have you guys finished thinking of the numbers that multiply to 48? Well, there's 1 and 48. There's 2 and 24. There's 4 and 12. And in case you haven't noticed, 12 minus 4 equals to, well, 8. The two numbers are 4 and 12. We move on. Ashley takes care of her neighbor's pets for $3.50 a day. Oh, that's really cheap. Considering the rates nowadays, that's really, really cheap. How many days would she need to work to earn $31.50? Ambitious. Now what could we use? We could draw a diagram, but that would be, well, time-consuming. We could use logical reasoning. We couldn't really work backwards. And we could technically solve a simpler problem, but it's more of a logic thing. Well, no, it's more of a math thing, but unfortunately there isn't a I just use math option. Slash math. I'm just gonna write that down. Don't actually do this on your papers or else the teacher might get angry, but So what's 31.50 divided by 3.50? Well, we're gonna take the 0 off to make it shorter. And then we ignore the decimal place because we don't usually use decimal places like this in long division. And we get 9. She needs to work 9 days. Done. So we're going to move on to the next section. Remember, you can take a break whenever you want. Subtract decimals. This is like adding decimals. You can use models, but are you really going to color the first number and then cross out the number of squares the second number is, and then you count all of the squares that aren't crossed out? No. Don't do that. Please don't do that. If you do this, it's fine if you do this in grade 4. It's just that if you keep doing this, by the time you finish middle school, people are, no. You're going to find yourself knee deep, well, no, not even knee deep, neck deep in trouble. So just use paper and pencil. And then you just subtract like normal. Over here, you might need the 0 as a placeholder to help you. So you do this, you regroup, blah, 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 and then this would become 6. 6 minus 5 equals to 1. This would be equal to 0. The answer to this question, 1.7 minus 1.59 equals to 0.11. So it might ask you to use the space below to draw models, but are you really going to draw all of it? Please say no. Let's just use it to show rough work then. 1.8 minus 1.2. What is 8 minus 2? 6. And then we have the decimal point there. What is 1 minus 1? 0. 0.6. Again, this is like addition in that you line up the decimal place. You don't line up anything else, you just line up the decimal point. If the other things just happen to line up, well then hooray. 5 minus 8, you can't really do that, so you have to borrow, quote unquote, from the next number. 15 minus 8 equals to 7. This number is a 2. 2 minus 0 equals to 2. 1 minus 1 equals to 0. So then this would be 0.27. Over here we have 0.9 minus 0.5. What's 9 minus 5? 4. And then we just drag this over because there's nothing to subtract here. Equals to 0.4. Now over here we have 1.7 minus 0.48. We're going to use a 0 as a placeholder. We can't do 0 minus 8, so we borrow a number from here. And we get 10 minus 8, which is 2. And this is 6 now, so 6 because we borrowed, loaned. 6 minus 4 equals to, well, 2. And then 1 minus 0 equals to 1. So 1.7 minus 0.48 is equal to 1.22. 2 twos. 1.25 minus 0.18. 5 minus 8 doesn't work, so we're gonna borrow a number from here. And then we have 15 minus 8 equals to 7. 1 minus 1 equals to 0 because we borrowed, remember? And then 1 minus 0 equals to 1. I should probably do the borrowing sign. And we just get 1.07. 1.25 minus 0.18 equals to 1.07. 0.5 minus 0.05. We're going to use 0 as a placeholder again. We're going to borrow because 0 minus 5 doesn't really work that way. 10 minus 5 is 5. Now this is 4. 4 minus 0 equals to 0. And we just move these down because there's nothing to subtract here. .5 minus 0.05 equals to 0.45. Now we're on the last two questions of this chapter. 0.8 minus 0.25. 5, well, we need a placeholder above that. So 0 minus 5, borrow. 10 minus 5 equals to 5. Now, since we borrowed, this is 7 now. 7 minus 2 equals to 5 again. And 0 point is just here, because there's nothing to minus, well, subtract. And that's, well, that. 1.65. Oh, we just have a trick over here, because this is addition now. So, 5 plus 0 equals to 5. 6 plus 3 equals to 9, and then 1 plus 1 equals to 2. .65 plus 1.3 equals to 2.95. We're done this chapter, and I'll be seeing you next time. Oh, and also, don't forget to do your homework.